Ladies and gentlemen, welcome back to our program. My name is Siim Lepisk. On daily basis, I work as innovation manager in SEB Bank, and I have a pleasure to moderate the conference. So, the specifically interesting part, the economic impact of AI, is about to start, and we have two keynote speakers and then a panel on the financial aspect of the AI. And so, the first keynote speaker, Peter Sarlin, is the co-founder and CEO of Silo.AI. And he's also professor of practice in Hanken School of Economics. He's PhD in machine learning with a special interest in applications for financial, economic, and societal disciplines. Please welcome on stage, Peter. As a warm-up question also I have to you, you have a PhD degree in mapping financial stability with AI. And at London School of Economics, you're still researching what could trigger our next financial crisis. So in today's context, what do you think, what are the key systemic risks and how to mitigate them before we jump into your keynote?
Yeah, that's an interesting question. So thanks for the kind invitation and the introduction. Yeah, indeed, the question takes me back to roots. That's the original topic that I worked on since, say, 10 years ago, and we've been working very closely with central banks across the world on building machine learning-based solutions for financial stability surveillance. Now, what the specific risk of today is a difficult question, but I think it's an intriguing problem from a machine learning and AI perspective to understand sort of all the various types of financial threats and risks for the financial sector, but also to understand the complexity of the sector and interlinkages across entities and how risks spread in finance. And these are the things that we have been working on the modeling side. I do actually think that there is quite a lot of similar risks that we had back in 2007 and 2008 that we still have in the system, and a lot of that is related to sort of boom-bust types of cycles, and running with very close to zero or zero interest rates for a long time then certainly puts us in a place to still be risky, but I'd suggest we, rather than digging into the details of financial modeling, we try to connect with actually sort of real-world applications and how AI comes into that space.
Great, let's take a look. The stage is yours. Thank you.
All right, so it's a pleasure to be here. What I will do is that I will try to sort of demystify what we actually mean with artificial intelligence, and I'll try not to be very technical, but I will sort of cover topics that basically go into what we can and what we can't do today. I think there's a lot of sort of hype around AI and AI applications that is actually not relevant at all for the discussion. And I think that also has a lot of impact on the discussion related to risks and regulation and so forth. But I think the baseline for everything is to understand what we are actually talking about when we talk about AI. So hopefully this will clarify something about that, and then I will basically talk about a little bit about the way that we look at AI at Silo.AI. So we are basically a company at the moment of approximately 42 people, I think now today, and we're a bit more than 1 year old company that was founded by myself, the former CTO of Nokia, and a few other senior co-founders, and most of us are sort of with a senior background in machine learning, natural language processing, or computer vision. And what we basically do is that we build customized machine learning-based or AI-based solutions for our customers. We obviously have also a few product development projects, but we are basically an AI lab that builds what we call AI for people, and that's what I'm going to connect to in the talk as well. So sort of the world that we want to build is a world with human-centric AI, a world that is basically making sure that machines are doing the repetitive labor, the repetitive work, and allows humans to focus on more meaningful work, creative tasks, and similar. And I think that has a lot of impact also on how we should be viewing sort of the regulatory side of things. I have basically 4 takeaways, which I'm going to touch upon, and I'd suggest that we use this as a basis for the discussion later on. The first one is that we only basically have narrow AI today. The second one focuses more on what machine learning actually really is about today. And the third one on how we sort of should be viewing business on top of machine learning and build model-driven business. And then the fourth one is sort of the way that we usually build solutions, which very strongly have a human in the loop. So very rarely we have fully autonomous AI. And I think that impacts a lot the discussion also around what AI actually is and how it should be treated. So speaking first about the state of AI, this is sort of the ex machina type of a view on these humanoid robots that are taking over the world. Is quite often the way we look at AI. Now, this is very far from what we actually have today, right? That said, I do believe that the world is changing, and I do believe that AI has a significant impact on the change in this world. But basically what is happening, when you open the newspaper, what is happening is that certainly there's a lot of hype, but most of the concrete things that are being built are very narrow in scope and very specific in scope. And just if you look at sort of the example here in the middle, these are concrete things that are happening at the moment. So basically, the fact that you can automate some of the work that humans are doing today has a significant impact, but it's not the humanoid that is taking over the organization or the world at the moment. Now, without going into a deep discussion of what actually AI is and how to define it, I think you could spend a lot of sort of philosophical discussions around the topic, but usually you want to relate it to sort of mimicking intelligent human behavior in one way or another. Now, a lot of the developments that have happened, we've had AI hypes in sort of several waves. What has happened today is that we've had significant developments in machine learning, and especially in processing various types of new kinds of data sources, such as language in various form and images, video in various form. I think a lot of our focus at least is on this, and I think a lot of focus overall in the market is on these types of applications of AI at the moment. Now, without going deeper into that, I think the sort of when we talk about risks, we quite often go into this sort of this future of superintelligence that somehow takes over the world and has an impact on everyone in touch with technology. And now superintelligence as such is interesting. Nick, I had a chat with Nick last year on the topic, and obviously Nick Boström, who is the author of Superintelligence, is a great philosopher and has a lot to contribute on that. But a lot of that is quite far from the reality today, right? We don't have superintelligence, and we're not going to have superintelligence in the coming years. General artificial intelligence, which basically is intelligence at the level of a human, it's also something we don't have today, and we can put anything between the Pepper robot that is pretty simple and an ex machina and try to understand what that is, but actually sort of finding a very good definition of what the general artificial intelligence is, even as such, is difficult. Now, what we have today is narrow AI, basically one-to-one mappings between various types of data sources. So from speech to words, from images to categories, from faces to names, from photos to captions, and so forth. And you have technologies like Siri, like Google Translate, that are basically based upon some of the machine learning developments and allow you to automate certain tasks with uncertainty. This does have a significant impact. I do believe there is a lot of value in that, but it's not taking over the world. Now, from a risk perspective, which was previously touched upon, there certainly is a lot of things that we need to be concerned about. And I think if you are familiar with the discussion around slaughter bots, then that certainly is something that we should be considering concerned with, because this is not far from today. This is what we have today. So drones that have cameras, sensors, face recognition capabilities, and shaped explosives. And this is from a Stanford keynote where it's actually the drone is thrown in the air and hits the doll. And this is technology that we have today. So certainly we need to be concerned about that. Now, the machine learning that we have today is often framed as something that basically learns on its own and takes over tasks. And that's not really what it does, right? So the way that you can define it is computers that learn without being explicitly programmed, which I think is an okay definition of the algorithms that we are building, right? Now, you often divide that into various types of categories of learning. And I'm sure the audience here is familiar with some of the basics in machine learning and knows what these are. But just briefly repeating what you have in the case of classifying, for instance, cats and dogs, is supervised learning, where you basically teach a machine by giving it a lot of images of cats and a lot of images of dogs and labels for them. Unsupervised then somehow does that without you actually telling it which is a cat and which is a dog. But the reality there is that it's only looking at similarity in the sense that this actually happens to look a little bit like a cat, so it's grouped. And this is actually not wrong, this is right. And then reinforcement learning, which is something that we talk a lot about. And this is what, for instance, DeepMind has been making use of in AlphaGo, so solving the Go game and being better than a human, and even starting from not knowing anything to becoming better than a human. And that's applied to chess, that's applied to Atari games, and so forth. But the challenge is that it requires basically you to be able to define what an agent is in that context, what actions, say a move on a chess table, what's the environment for that, and how you reward various types of moves on a chess table. In the real world, we rarely have that type of a setup. So you can't take really like AlphaGo and just apply it in, say, credit scoring, because you don't have this type of an environment. So I think 95% of what we have today is this. You can still do magic with that, but it's supervised learnings. And that's basically computers that learn from examples. It's not more special than that in a sense. And then you can support it with various types of more recent technologies. Supervised learning comes from back in the early 20th century. And then you have various new strands of technology that allows you to solve these types of problems. Now, without going more into detail in the Turing test, I think Turing nicely puts in his paper, so the Turing test is is basically a test of a human being that is unable to distinguish the machine from another human being. And what Turing also suggests in his original paper on the topic is that you should design a machine like that is like a, well, he says child, because then it actually makes the test easier, right? So that's one of the things you can do. But the other thing that you can do, which I think is interesting in a sense also, is that you can relate a lot of the activities in the human brain and the way that children learn to the way that machines learn. So if we look at the same case of classifying cats and dogs and relate that to the way that children learn, then you can relate a lot of the more challenging sort of technological concepts to this as well. So supervised learning was what we discussed earlier. It's learning from examples. So you tell a child, this is a dog, this is a cat, this is a dog, this is a cat. And the machine learns basically to solve that classification problem. Then gradually the child starts to basically posit to get feedback, to do Q&A on the book. And you basically give guidance when the child asks you a question, and you learn more. And that's what you call active learning in machine learning. And then transfer learning is when the child goes out from the book, goes out, and in 3 dimensions sees a dog. Then you actually solve an entirely different problem. But you transfer from what you learned earlier to a new environment. And that's also what you can do with machines today. And then you have this sort of maybe more futuristic topics is reinforcement learning. I guess what you can do is that you can put a candy up here and reward a child for picking up the dog or picking up the cat. And that would actually be rewarding or penalizing for actions in a reinforcement learning type of a setup. Now, I don't think that actually works, and I don't think really unsupervised learning either works today in such a way that we would expect. Okay, now how do we connect this to business? Closed loop data for model-driven business. Let's try to open up this. So Horowitz actually, there was an interesting article in Wall Street Journal in 2007 by Horowitz, a famous investor, that said that software is eating traditional industries. And he pointed out to several of these companies, which in 2007 wasn't really the truth and ended up being quite a good of a prediction. Now, model-driven businesses or business accelerates it, and that's what several of the same companies have been doing. So they've been putting learning models at the core of their business so that every single interaction makes their product better. They get more users, they get more interactions, they get a better product, and so forth. So that's when it comes to recommending music, that's to recommending books, that's to recommending movies, that's to ranking searches, and so forth. Now, this basically means that what you should be going after is closed-loop data. So data that you are creating, but data where you also are always getting a feedback on, because that allows you to become better and better and better with every single interaction. And now when we think about this, who is actually in a position to do this at the moment? Is it the early stage startup companies, technology companies, or is it actually the traditional industries or traditional companies? In most cases, it's actually the traditional companies that have an edge today. And I think that is something that we don't necessarily always realize, that currently the opportunity is with traditional companies rather than these very sort of advanced tech-focused young companies that don't have any data, no operations, no customers, nothing. Obviously, there's a lot of risks and challenges with that. There was some discussion on this already. And I'd be happy to go into this, but that would be a discussion of its own. But Amazon had an example of biased data recently, a recruitment AI that was recruiting only men because their their training data only or mostly included men rather than women. Biased metrics, I mean, it's going where you measure. So basically, if your metric is not defined in such a way that it actually measures the utility you want to get out of it, or if it's not aligned between the company and the users, then you might have challenges there. Tricking machine learning models, example could be a self-driving car that has been shown with so-called adversarial solutions, where you basically twist a little bit an image of a stop sign, for instance, and you can't recognize it anymore when you're a machine. A human would do so, but not a machine. And eventually black box models. And the way that I want to sort of package this, and what I believe is a solution to many of these challenges, is in a sense essentially how we create trust between the human and the machine. And I think that's through basically interpretability. And that's at the core of most of the things that we do. I personally think it's total myth that we have sort of black box models, or that we don't understand what the neural network is doing. I mean, we don't understand what humans or why humans are suggesting certain recommendations or certain solutions. And sometimes the models are complicated. We don't understand them necessarily, but we understand the predictions. We certainly know why we are recommending, for instance, that this doctor should be taking certain types of decision. If we get a black box signal with no basically interpretation to that, then it's difficult to take a decision. But if we do get that, then you can take a decision, you can be accountable for the decision and so forth. And now going back to the cats and dogs, the same applies here. We know precisely why we are basically signaling this as a dog and this image as a cat. We know the pixels that contribute to the neural network in the background that says that this is a cat. So it's just a myth that it's a black box, in the sense that we do know why the predictions are actually coming out. Okay, human in the loop. There are three challenges. One is the need for data. Quite often, in many cases, when we work also with companies, they don't have labeled data set from the very beginning. Put models into use to collect more labels, more data. Tech maturity is often low. We can't, in most cases, automate the end-to-end process, but what we can is augment and support humans when they are basically solving the problems that we focus on. And then eventually, it's much tougher to change processes and people rather than basically find the processes that they already work on and then try to help them along the way. And that's why in most cases, this is also the reality when you look at what others are doing. You might call it AI and you might call it various other things, fully autonomous systems and autonomous cars and blah, blah, blah. But actually, usually it's the interaction between a human and a machine that you are focusing on. And you have a human in the loop or human on the loop in certain cases. And that's with cars, autonomous cars as well. And there the focus is obviously having models that generate certain types of outputs, but then having humans that confirm, reject, and eventually label outputs to give you more feedback so that you can learn even more when a solution is in use, and then eventually get those labels back to your existing models. Now, that relates to usually three stages. One is how to get more data and labels. One is how to basically get started and improve the training phase of a machine learning model. And the final is, once it's in production, it's already a product as such, how do you learn from user behavior when an AI-based solution is in production? These are some of the use cases that we have been working on. We basically have solutions for various ways of processing documents or language. We have solutions for processing images. We have solutions for processing numbers. And in that specific process, also getting in feedback on the specific underlying AI that helps you in your tasks. So when you are, for instance, dealing with documents, this could be something that helps a human analyst. In this case, we have two different applications. One is actually a project that we did related to the first question here with central banks on risk assessment for around banks and doing so on news data. And the other is on investment decisions and investment prospectuses. Basically what it means is that in this case, for instance, you have a Reuters news feed that gives you all of the news covered that is covering banks and identifies sentences that relate to bank distress. And you have a risk analyst that gets a feed that suggests that here's bank distress, here is not, and allows you to give feedback to the model output. The same applies to investment documents. Here you have investment prospectuses coming in to a risk analyst. These are 200-page documents. Rather than spending a few hours reading those documents, you could as well have a machine that gives you a feed of, say, 10 to 20 different paragraphs or sentences that you should go through and accept and reject. And this is quite a different world compared to what we usually sort of face when we discuss sort of autonomous systems and AI that's taking over the world and so forth. In most cases, this is what we are doing. And if you think about basically Google, that's what Google does. It ranks your search and then basically you pick one of them. And that's what your interaction with the Facebook feed is about as well. And that's what Amazon, Spotify, Netflix recommendations is about as well. It's basically having a machine suggest you something and then making use of your own intelligence to pick the best out of that. And if we are able to basically bridge this gap between sort of the view of the machine and the view of the human, then we feel that we have been sort of successful in our own mission on building AI for people. Thank you.
Thank you. And we do have a couple of questions from the audience already on Slido. Two first ones are about artificial general intelligence, AGI. First, according to predictions, we will likely have AGI in this century. Is it useful for some people, for example, Nick Bostrom, to do research on problems related to that? What's your belief? How soon it will be, and is it worth spending time on?
According to the definition that I have of AGI, I don't think we are going to have it this century. But I mean, I think it's extremely important that we do research like the one that Nick has been doing and many others have been doing. So I think that is, it's research. It's worth remembering that it's research. The same thing applies to what DeepMind is doing around reinforcement learning. That's also very important research. And then it's a difference between what then actually is being done in the real world. And I do think that once we basically take some of the narrow artificial intelligence today and then put together very in a smart way specific sort of AI or machine learning based or AI based tasks, then we can create something that is pretty close to what we would sort of presume AGI to be. And you can think of a self-driving car, for instance, being a case like that. You have, like in a sequence, several very specific modeling problems that you are able to solve. And when you put them together, then you can do good things. And the same allows you basically to do, say, surveillance and security as well. It's not just one modeling problem. It's just you putting intelligently several pieces together. On that note, there's a very intriguing question on Slido as well. So how do you really know that there is no AGI? If I would have it, I would keep it secret. Yeah, I mean, certainly there could be. It's not going to be based on the technologies that we are aware of, though. So, I mean, we can do supervised learning today, and we don't have, basically, we don't have anything in the real world today, as far as I know, at least, that would be different to that. And I think I have personally no idea how you would put together reinforcement learning in such a way, for instance, that it would actually be an AGI. So I'd be curious to hear what the technology behind an AGI is.
Absolutely. All right, now thank you very much for now, Peter, and let's give a warm round of applause.